Hello, I'm Kushi Patel,
And I'm Carissa Serber.
and our research project is on the pH of citrus fruits.
As previously stated, our chemistry research project is over the pH of citrus fruits. Certain foods, mainly fruits, are widely known to be sour and or acidic. This main idea of acids and bases was developed by scientist Robert Boyle and is known as the pH scale. By the pH scale, acids can be labeled to have a sour taste, can be corrosive, and can lose their acidity when combined with a base. Through using the pH scale, scientists can now use pH probes to find the actual acidity of any substance, such as fruit juice. The purpose of our experiment was to find which fruit, out of which we had chosen, is the most acidic, which can aid scientific discovery of how an acid can affect the human body. Our problem was, what is the difference in acidity between different types of fruit, such as oranges, grapefruit, lemon, strawberries, and pineapple? And our stated hypothesis was, if different acidity in fruits are tested, then the lemon will be the most acidic because it has the most sour taste. Now going back to our purpose, the pH of the human body can change depending on how much acid one intakes. The side effects of containing too much acid would be to catch a case of acidosis. Now, acidosis is a sickness where the body is unstable and contains too much acid. If one was to come down with acidosis, this experiment could potentially cure the condition quicker and neutralize the body's pH levels faster.
Materials that we used for this project were 5 different types of fruit. We used oranges, grapefruit, lemon, strawberries, and pineapple. Also, we used a knife, paper towels, and 5 bowls so that we could cut and squeeze the fruit juice into 5 graduated cylinders. Some of the general lab equipment that we used was a vernier pH probe, a LabQuest, and a computer. We also used a funnel so that we could squeeze the fruit juice into the graduated cylinder much easily.
We used a vernier pH probe for this experiment. When not used, this pH probe was stored in a solution to keep it neutral. The sensor had to be connected to a computer by Bluetooth, and the LabQuest was connected to it also to make the graph show up. Before and after we used this pH probe, it was rinsed out with distilled water. When using this pH probe, we stuck it in the fruit juice and let it settle for a while, and then the data came up on our computer.
To do this experiment, we had to connect a Logger Pro to a computer and connect it to the pH probe in order to get it ready to use. Second, we had to cut all 5 of the fruits. Once again, it was the orange, grapefruit, lemon, strawberry, and pineapple into the graduated cylinders. Use each of them cut in half by knives and squeezed. Third was to rinse the pH probe with distilled water and place it into the graduated cylinder for a couple seconds. Step 4 is to record the pH of the fruit and repeat the trial 3 times in order to make sure that the results are accurate. And the 5th step is to place the pH probe back into the solution when it is not being used.
The objective of our experiment was to identify the difference of acidity in a variety of household fruits. You can see through this table here and the graph our data over the 2 lab days that we recorded our data. We collected the pH of various fruits throughout the course of 2 days, and on the graph we included standard deviation, which is the measure of dispersion of a set of data from its mean. The main fruit that showed a significant number in standard deviation was the strawberries. We believe this might have been caused by the ripeness of each individual strawberry. One might have been riper than the other, and this all considering that we did come back for day 2 of the lab and we did not put the fruit in the fridge, and so the fruit may have become stale, lowering or making the pH higher. Following our data collection, our initial question was answered as to which fruit was the most acidic, which was the lemon. However, our collection may have not been perfect because the pH of each fruit did not stay the same. This may have been caused by the ripeness of fruit, like we said, and the pH probe solution may have gotten our other juices in it. Our juice may have gotten other substances like water or the pH probe solution, which may have given the incorrect pH. All things aside, we did make sure that our lab procedures stayed consistent.
In conclusion, our hypothesis was proven correct, which was that the lemon would be the most acidic, which it was because it had a pH number of 2.4, which was less than all the other fruits. From this experiment, it was learned that fruits that have a sour taste have a pH level of less than 7. For example, all of the 5 fruits that we tested were sour and had a pH number of less than 7. Something that could have affected the data that we got was the ripeness of the fruit, because our data was collected over a course of a couple days. In between these days, our fruit could have ripened a little bit more, which explains why our pH for the same fruit was different each of these days. Lastly, there are higher technology pH probes, such as the benchtop meters, that need automatic temperature compensation, or ATC, which gives it a more accurate pH even if the solution has a different temperature. These pH probes are meant for more intricate experiments that require more technology and used in solutions that we did not have to use in our experiment. Different pH probes are made to test different things, such as the single junction reference, which works for most solutions except for heavy metals, proteins, organics, and low and high ion concentrations. Unfortunately, these pH probes are not available in the chemistry lab, and they're used for way more complex experiments, which are unnecessary in this particular one because we are not dealing with any type of solutions.